see volume of revolution. So integration can help us to find area and also volume. Okay, we have two types here. First one is volume of revolution rotated about the x-axis. So the volume generated when the region bounded by a curve. Okay, so this is a curve y equals to fx. The lines x equals to a. Okay, so this is the line x equals to a and x equals to b is rotated through 360 degrees about the x-axis is given by this formula. Okay, so first look at this diagram. So the area bounded by this curve and these two lines with the x-axis is this part. Okay, this part. So if I rotated this area 360 degrees about the x-axis, so I rotated it 360 degrees, rotate it 360 degrees, then what will we have? We will have a solid like this. Okay, a solid like this. This solid. Okay, the volume of this solid will be V equals to integrate. Okay, because this is from A to B, so from A to B. Okay, pi, or you can leave this pi outside also can. Pi, because this is x coordinate, so we integrate it in terms of x. And then this one is x, we have to put y at the center. And this is 360 degrees. Okay, this is a 3D one, so we have to put square. Okay, so this is a formula for volume. Okay, let's look at the 3D diagram. Just now we have the curve y equals to x squared. Okay, so this is y equals to x squared. And let's say my A just now is 1. So 1 and B equals to 2. Okay, so the area bounded by this curve and x equals to 1, x equals to 2 together with the x-axis is this blue color region. And then when I rotate this blue color region 360 degrees, what will I get? Okay, so you notice 3D diagram here. When I rotate it 360 degrees, so I will have a solid like this. Okay, I will have a solid like this. And the volume of this solid, we just use the formula just now. Pi, integrate from 1 to 2. Okay, because this is x coordinate, so we integrate it respect of dx. Center here, we have to put y squared. Okay, and y equals to x squared in this question. So we put in x squared. So x power 4. Integrate this, you will have 1 over 5 x power 5. Then you substitute into 6.4 minus substitute in 1, 0.2. Okay, so the answer is 19.478. So the volume of this solid will be 19.478. Okay, so first type here is rotated about the x-axis. And now, second will be rotated about the y-axis. So rotated about the y-axis, we have the curve x equals to fy. So this is the curve x equals to fy. Y equals to a. This is the line y equals to a. Y equals to b. Okay, so the area bounded by these three lines with y-axis is this one. When I rotate this area 360 degrees about the y-axis, okay, I rotate it 360 degrees. Rotate 360 degrees. Then we will have a solid that look like this. Okay, this part. The volume of this solid will be V equals to integrate from A to B, and then pi. Because it's y coordinate, so we integrate in respect of y, dy. So center here we have to put x squared. Okay, do remember this square. Okay, sorry that I can't find the 3D diagram for this one, so you just imagine. Okay, we rotate it about the y-axis, and then we will get a solid like this. Example 23. Find the volume generated when the shaded region is rotated through 360 degrees about the x-axis. So when we rotate this area 360 degrees, what will we have? So we will have a volume that looks like this. Okay, because I rotate it 360 degrees, so you will have a circle like this and curve. Okay, so this is the solid that I will get. Okay, let's look at the 3D diagram. Okay, so the curve is y equals to square root x. Then the lower limit is 1, upper limit is 2. Okay, this is the area bounded by the curve together with the x. If I rotated this area 360 degrees, then what will we get? You focus on here. I rotate it 360 degrees. I will have a solid that look like this. The volume of this solid, I just use integration. So pi integrate from 1 to 2. Okay, this is y. Y equals to square root x. So square root x square, then dx. Okay, integrate this one. And then you will have 1 over 2 x squared from 1 to 2. Then you just substitute in a value to find the answer. Get to the questions here. So integrate from 1 to 2, from 1 to 2. And this is x coordinate, so we put dx here. And then pi y squared. Y equals to square root x. So you have square root x equals to x power 1 over 2 square. 1 over 2 times 2, you will have x. Then you integrate this one. The final answer will be 1 and 1 over 2 pi unit cube. Okay, the unit is unit cube because this is the volume. Example 24. The region bounded by the curve y equals to 4 minus x squared and the line y equals to 4 minus 2x is rotated completely about the x-axis. Find the volume of revolution. Okay, so we focus on the curve here. When I rotated this curve, okay, this area, 360 degrees about the x-axis, then I will have a solid that looks like this. Okay, this is the volume generated by the curve. And then now we focus on this straight line. The area bounded is this one. When I rotated this area 360 degrees about the x-axis, then I will have a solid that looks like this. Okay, this is a cone. Okay, the purple color one. This is the cone. So the volume generated by this shaded region equals to the volume of this curve, the red color, minus the volume of the cone. Let's look at the 3D diagram. Okay, so the equation of the curve is y equals to 4 minus x squared from 0 to 2. Okay, when I rotated it 360 degrees about x-axis, then I will have a shape that looks like this. Okay, looks like this. The volume of this solid will be integrate from 0 to 2 pi y squared. Y equals to 4 minus x squared. Then square dx. Okay, this is the answer. This is the volume generated by the curve from 0 to 2. Okay, the volume generated by the straight line here, 4 minus 2x from 0 to 2. So when I rotated it, when I rotate this area 360 degrees about the x-axis, then I will have a volume that looks like this. Okay, this is a cone. Okay, you can use integration to find this volume also. Integrate from 0 to 2, and then this is the equation of the straight line, 4 minus 2x. Then don't forget square in respect of dx. Okay, so integrate this, you will have 33.51 unit cube. Okay, because this is a cone, we can also use the formula of cone. 1 over 3 pi r squared h. So r is the radius. So the radius is this one. Radius equals to 4. H is the height. So this is the height. Height equals to 2. Back to the questions here. So the volume generated by this shaded region, we have to use the volume generated by the curve minus the volume generated by the cone. And this will be the remaining part. The volume generated by the shaded region. Okay, so volume generated by the curve, this is the formula, minus volume of a cone. Okay, so 1 over 3 pi, r is the radius. So just now I show you that, like this, this is the cone. So the radius is 4, the height equals to 2. So you have 4 square 2. This is the volume generated by the curve. Integrate from 0 to 2 pi, y equals to, okay, the formula for the curve, 4 minus x squared, 4 minus x squared, square dx. So this is the answer. Example 25. Find the volume of revolution when the area bounded by the curve y equals to x squared. So y equals to x squared, y equals to 1, y equals to 4 is rotated through 360 degrees about the y-axis. Okay, so the area bounded by this line are this one. When I rotated it 360 degrees, you imagine, so rotate it 360 degrees. Rotate it 360 degrees. Okay, we will have a solid that look like this. Okay, this is a solid. To find this volume, so we use integrate from 1 to 4. From 1 to 4, okay, because this is y coordinate, so we have to integrate in respect of y. Okay, don't forget the pi. And the center here will be x squared. X squared equals to y. So you will have pi integrate 1 to 4 y dy equals to pi. Integrate this one, you have y squared over 2 from 1 to 4. Okay, substitute in the value. You will find the answer. 7 and 1 over 2 pi unit cube. Example 26. Okay, find the volume generated when the shaded region is rotated through 360 degrees about the y-axis. Okay, so we rotated this part 360 degrees about the y-axis. Okay, imagine we will have this one. We will have a shape that looks like this. Okay, so the formula to find this volume will be integrate from 0 to 2, okay, pi. This is y coordinate, so integrate in respect of y. Then center here we have to put x squared. Then what is x? We are given y equals to x power 1 over 2. When I square both sides, okay, I square both sides. Then we will have y squared equals to x. So x equals to y squared. So you just put it here, x equals to y squared. So y squared square again, you will have y power 4. Okay, solve this. Example 27. Find the volume generated when the area bounded by the curve y equals to x squared and the line y equals to x is rotated completely about the y-axis. Okay, so this is the curve y equals to x squared. Okay, because a coefficient of x squared is positive, so this is a smiley face U shape. Y equals to x is a straight line like this. Okay, so the area bounded by this curve and the straight line here is this one. 就是它们两个包围着的面积是这里。Okay, so first step we have to find the intersection point of the curve and the line. We have to find this point. So we substitute in y equals to x to here. Then you will have x squared equals to x. Okay, solve this. X equals to 0, x equals to 1. So these are the intersection point. Intersection points. Okay, first is x equals to 0. So this one. And x equals to 1 here. So the coordinate of this point, this is 1. Then you put in 1 into this equation. So y equals to 1 also. Okay, so that means this is 1. This is 1. To find the volume generated by this shaded region, first, okay, so we focus on this curve first. So this curve is from 0 to 1. Okay, we are using y coordinate. From 0 to 1, this area, this green area. Okay, if we rotated it 360 degrees about y-axis, then we will have a volume that looks like this. Okay, can you see that? The green solid one. Okay, so this is the volume generated by the curve from 0 to 1. Integrate from 0 to 1 pi. Okay, this is y coordinate, so we put dy. So center here we have to put x square. So what is x square? X square equals to y. So we integrate y dy. Okay, solve this. This is for the green part. Okay, for the shaded region, we still have to minus this one. The volume generated by the straight line. Okay, so when we rotated this 360 degrees about the y-axis, then we will have a solid that looks like this. And this is a cone. So we just use the formula of a cone. 1 over 3 pi r square h. So what is the radius here? This is 1. The height also 1. So lastly, we just use the green solid here minus the purple cone. Then we left with the blue shaded region. Use the volume generated by the curve minus the volume of a cone. Okay, so this is the answer. 1 over 6 pi unit cube. SPM for map sample 5. The diagram shows part of the curve. Find the area of the shaded region. Okay, so this one you can divide it into A and B. For A, the shaded region will be integrate. This is from -1 to 0. -1 to 0. Then this one you expand. So this is equals to x squared minus x plus x minus 1 equals to x squared minus 1 equals to x cubed minus x. So x cubed minus x dx. Okay, this is for A. For B, we integrate from 0 to 1 and then x cubed minus x dx. Okay, for B you will get a negative answer because this is below the x-axis here. Okay, this will you will get, for this you will get negative. So the total you just A plus modulus B. B, the volume generated if the shaded region from x equals to 0 to x equals to 1 is rotated completely about the x-axis. Okay, so for this part only, when we rotate it 360 degrees, what will we get? Okay, so let's look at the 3D diagram. Okay, so this is the curve y equals to x cubed minus x from 0 to 1. So this region, when I rotate it 360 degrees, okay, I rotate it 360 degrees, then I will have a volume that looks like this. Okay, this one. Okay, so to find this volume, we just use the formula pi integrate from 0 to 1 x cubed minus x squared dx. Okay, you integrate this, then you will get the answer. SPM for map sample 6. The diagram shows part of the curve and a straight line y plus 2x equals to 6. Find the volume generated when the shaded region is rotated through 360 degrees about the y-axis. Okay, so this shaded region, okay, for this question, first we look at this straight line. So we rotate it about the y-axis. Okay, so y-axis. So this area. When we rotate this red area 360 degrees about y-axis, then we will have a cone that looks like this. Okay, imagine yourself, this will be a cone. Okay, and then when we rotate this curve, this part, when we rotate it about y-axis for 360 degrees, then we will get a shape that looks like this. So when we rotate this shaded region, this will be the remaining part, this one. We just use the volume of cone minus this volume generated by the curve. Okay, so volume of cone 1 over 3 pi Radius 0 to 3, so 3 square. H is the height, 6. Minus, okay, this one you can use hemisphere or you can just use integration. Okay, this is y-axis, so 0 to 4, integrate 0 to 4. Pi, okay, this is y-axis, so dy. So center one we have to put x squared. So what is x squared? The equation of this curve is y equals to 4 minus x squared. Rearrange this, so x squared equals to 4 minus y. Okay, you just put in 4 minus y. Okay, solve this.